Today we are going to discuss about general bearing. How much amount of mass flow rate required for a general bearing if a heat generation takes place in a bearing. Here I draw a figure by red color. It is shaft and by blue color it is bearing. Where I write TOTBTA. These are showing temperature. TO is the maximum temperature of the lubricant that can bear without any failure. Means TO is the maximum temperature of the lubricant. After that the lubricant failed or the quality of the lubricant will degrade to its proper working. TB is the outer surface temperature of bearing and TA is ambient temperature, room temperature or atmospheric temperature. TB is the temperature of the outer surface of bearing. TO is the maximum temperature of lubricant that can bear without any failure. After that the quality of the lubricant will degrade or it will not function properly. So here this is shaft and bearing. In between we use the lubricant and heat generation takes place due to power loss. Power loss occur due to friction. So the main reason of the power loss is friction. So we try to decrease the power loss by decreasing the friction. So in this lecture we are going to discuss about the amount of mass flow rate or the mass of the coolant required to absorb heat from the lubricant so that it can work properly. Here I write heat dissipation will equal to HA delta T. This is the formula of the Newton's law of cooling and also known as convection formula. In solid, heat transfer takes place by conduction. In liquid, heat transfer takes place by convection, and in vacuum, heat transfer takes place by radiation. So we used here lubricant, and for lubricant is in liquid form. So for this we use convection formula or also known as Newton's law of cooling, which is equal to HA delta T. Here we have required the formula in terms of heat dissipation by the convection. In convection heat transfer by the natural phenomena. If this heat generation will more than the heat transfer by the convection, then we only used the lubricant, then we used only coolant. Otherwise there is no requirement to use coolant, but lubricant is essential for the proper working of the shaft and the bearing. So heat dissipation will equal to pi, area will equal to H pi dl. Area will equal to pi dl. This is peripheral area of the shaft, and TB minus TA is the temperature difference, where TB is the outer temperature of the bearing and TA is the atmospheric temperature. And I write a new term, that is CD. CD will equal to heat dissipation coefficient, which is equal to pi H, and the unit of this watt per meter square Kelvin, and this will CD dl TB minus TA. And to correlate these three temperatures, that is TO maximum temperature of lubricant that it can bear without any failure, TB outer surface temperature of bearing, and TA is atmospheric pressure. We assume that TB minus TA will equal to TO minus TA by 2 to correlate these three temperatures. Then we can exchange TB minus TA by TO minus TA by 2. Here I write heat dissipation will equal to CD, where CD is heat dissipation coefficient, D is diameter of the shaft, and L is the length of the bearing. Here D is the diameter of the general. What is general? The part of the shaft which is inside of the bearing is known as general. General is also a part of the shaft, but the part of the shaft which is inside of the bearing is known as general. So this will length of bearing, and we use the diameter of this portion of the shaft if shaft of bearing diameter. Suppose the shaft is of bearing diameter, then and the diameter of the shaft is this inside of the bearing, then we use this diameter, that is D1. This will not useful for us, that is D diameter. Then we used only the diameter. So the part of the shaft which is inside of the bearing is known as general. General is also a part of the shaft. So CD DL TO minus TA. Then what is the condition on which we use coolant? Then if heat dissipation is more than heat generation, then there is no requirement of coolant, and heat dissipation is equal to heat generation, then also no requirement of the coolant. But heat dissipation is less than heat generation, then we use coolant. Only in one condition we use coolant, that is heat dissipation is less than heat generation. Then we use the coolant will equal to MC Cp, where M dot C is mass flow rate of coolant, Cp is specific heat of coolant, and delta is the temperature difference between the maximum temperature and the coolant temperature. And we use the amount of coolant, that is mass flow rate of coolant, that is the difference between heat generation and the heat dissipation. The reason is that in industries we purchase these quantities, that is coolant and shaft bearing, in a large quantity, so the cost will very high. So we think that how we can reduce the cost. For this purpose we use the coolant, that is the difference between heat generation and the heat dissipation. So this is about the mass flow rate of the coolant required. Here for heat dissipation we use Newton's law of cooling, and this is also known as convection formula. For a liquid form we used convection formula, for fluids we used convection formula, for solid we used conduction formula, and for the vacuum we used radiation formula. And heat generation takes place due to power loss. Power loss comes in picture due to friction. So the main reason of the power loss is friction. TO is the maximum temperature of lubricant that it can bear. TB is outer peripheral temperature of bearing, and TA is atmospheric temperature. The part of the shaft which is inside of the bearing is known as general. So these are some basic thing. So this is about mass flow rate of cooling required in a general bearing. Thank you.